The chair and moderator for the session is Lieutenant General P.R. Shankar, Param Vishis Seva Medal, Ati Vishis Seva Medal, Vishis Seva Medal retired, former Director General Artillery. Sir, may I request you to kindly come up on the stage? The speakers for the session are Lieutenant General Dr. Rajesh Pant, Param Vishis Seva Medal, Ati Vishis Seva Medal, Vishis Seva Medal retired, former National Security Coordinator, PMO. Sir, may I please request you to join us on stage? The second speaker is Mr. Geo George Philip, Vice President, Big Bamboo Solutions Private Limited. Followed by Dr. K. Mohanavelu, Scientist, DRDO. The final speaker for the session is Major General Ajay Kumar Sharma, Deputy Commandant, MCE-ME. I now request Lieutenant General P.R. Shankar to kindly start the proceedings. Sir, over to you.
Thank you. Can I have the first slide? Right, thank you. Good evening, ladies and gentlemen, and members of the panel. We have a large panel, and we come to the third session, by which time, from the morning to now, 3/4 have run away. Okay, but having said that, I'll put across something new, and I'm sure my panelists will put even something more new. And this, hopefully, should be a very good session to go along with. Okay, where do I start? How do you... Yeah. Look, these are the military technologies of this century. And in this century, these technologies will rule. And wherever you go, however you do, this is what you're going to talk of. And from morning to now, if you've seen, you've not covered all of them. Right? You're talking a lot of data, AI, share, and all that. What do you do with it? Where's the cloud for it? Okay? What about medical? You're going to have casualties in the battlefield. That's where synthetic biology comes in. You want reach. No one has spoken of propulsion engines and aero engines and all that. Technology is just not AI and cyber. And the focus today, unfortunately, largely, has been on that. So you need to widen your horizon of thinking when you talk of technology for battlefield tomorrow. And unless you get this whole story right, you're out of the game. When you talk of battlefield technology, you're talking of nuclear also. What are you going to do in high altitude? Are you going to keep burning fossil fuels interminably and handle 2 fuel cells for a thing? The major elephants in the room are not being tackled by us. Okay? Right. The second question is, what do you do with all these technologies? You can't take them home. You can't put them on the battlefield unless you convert them into something else. Yeah, next please. And this is what you do. How do you convert each of these technologies into weapon systems? Right? And this is a matrix which you have to develop for each terrain. And this is a matrix for high altitude. Okay? You want to have battlefield transparency. It means putting 5 to 6 technologies together, integrating them and putting them in the right mix. You want to have reach. Again, you need propulsion, unmanned systems, guidance and control and everything. So that matrix gives you the basic technology which I showed you earlier. And this gives you the conversion of those technologies practically on ground, what you have to do. And that roadmap or that thinking or vision, do we have it? Or are you thinking on simple terms? Let me tell you, this both these slides I made about 1 year back. And where did I make it? I made it when I watched a conversation between the CEO of Google, ex-CEO of Google, Eric Schmidt, and the CFO of AI, OpenAI. And that was when OpenAI had just come up and ChatGPT had just started. I saw this conversation, and it is from there I derived these, and I added more, right? It's not the sum total of this, and this is what it is. And I've been speaking of these two very slides almost everywhere anyone talks to me or wants me to talk on technology. And just for your information, I've shown this to the Vice Chief and the CDS also. I've spoken to them. And I'm writing an article in depth for IDSA in their journal. Right? And I'll forward it to you when I finish it. But this is something which we have to think of. When you talk of battlefield energy, it is just not fuel cells. It's renewables. It's space-based systems. It's nuclear. You're looking at fusion. You're looking at thorium. If China can put a thorium or plan to think of putting a thorium molten salt reactor on a ship, why can't we take that same thing or something like that and put it in high altitudes and solve your problems? You are the largest amount of thorium. You are the biggest, what shall I say, researcher of thorium. Do we have that vision to think technology not for now, but 10, 15, 20 years ahead? That's the challenge. Yeah, next slide, please. Look at this. This is an interesting article which I'd like everyone to read. It's in Washington Post. It talks of what a Russian and Ukrainian general agree on. He says the battle space is different. I would suggest all of you in uniform and not in uniform read this article. Okay? Now, what are the main things? I'm not going to go into the thing. Next, please. He says traditional maneuver forces are sitting ducks. We are fighting an algorithm war. He talks of fog of war has cleared because of battlefield transference. Air defense triumphs over military aviation. No one spoke of air defense today. We just not spoken of it. It zinged air forces, and that is why Russia is still stuck in the borders of Ukraine and not been able to cross. Okay, you're looking at superiority in artillery, and you need radical rearmament, which is very important. We don't understand it. And last, the best weapons are small and cheap. Have we done a cost analysis of how we're going to fight? And that's what the latest technologies should lead you to, not make it costlier. Yeah, next please. Okay, you take a full thing, and in fact, for clause only I've done a research and article on rockets and things like that, because the proliferation of rockets, whether it's between Israel and Hamas, or in Russia, or the coercive use by North Korea and China, if you have a look at it, this is what comes out. You have the traditional weapons which are tanks, artillery, aircraft, infantry, they're there. You have still not handled those technologies. You need increased domain awareness, where you need space, UAVs, networking, AI, narratives. If you don't fight the narrative battle, you're out of the equation. And then the future weapons are UAVs, rockets, missiles, digital and space, and nuclear capability. No one's spoken of nuclear capability today. The Chinese fellow is tripling his arsenal. What are we doing? Isn't that capability development? Are we thinking of it? Okay. And then, let's come to reality. Hybrid grey zone war is a reality. That's the new normal. Are we developing and orienting our technology to this new hybrid normal? There's something which Subrata Saha did touch upon. Okay. Your operational ability and your operational clairvoyance has to be clear. Otherwise, the technologies you're going to go after are fake. Okay, next please. Look, as far as technology is concerned, you must understand the best technology is that which wins you the battle. It might not be the latest technology, right? And you see again a thing was given, Vietnam, Afghanistan. What does it prove you? You don't need great technology to win battles. You need that technology which you need to win a battle. The cheapest and the most effective technology is one which you own. It might be the lowest form of technology, but that's the best technology. Don't go for the best solutions, go for the optimum solution. Don't go for what China has done. Stop aping China. Whatever China has done, no one knows whether it's going to work in war or not. But what you have done, based on your operational experience, if you do a little upgradation, you are better off. You can defeat the Chinese or Americans or whoever it is. Right? The costliest technology is what you buy or import, and that's what we've been doing for 75 years. Time to change the game. Okay. Technology upgradation is the name of the game, not new technologies, new weapons, new shiny equipment. And we have not spoken of it today. How much are you investing into upgradation of existing systems? Half your missile systems can be upgraded by better propulsion technology. We have not spoken of it. That's why I'm trying to talk something else. I'm talking something different from AI, cyber, and those 3-4 click words. No. A lot of technology is happening in the old brick and mortar space, which you need to make everything. Right? There is no choice but to make your own technology. And we need a national strategy for military technology. I'm not talking of an armed forces strategy. It's a national strategy which we need, which comprises original research, upgradation, substitution, import substitution. Have you thought of it? Have you gone into a process form of reverse engineering? Big question mark. Right? And that's part of technology, because if you reverse engineer, you know that technology, tomorrow you can evolve into something else. Whole day today, we are talking of revolutionary technology. Where is that evolutionary technology where the Soviets have progressed from T-34 tank to T-90 tank, and now they've gone to T-14 Armata? You want to make that Armata like we made Arjun. Did we start with T-34? Or today what you have is your T-34 of this century. Can you evolve into the next? Or you want to just revolve? Big question. Okay, then what about alternate strategies? If you, a thermal imaging, cooled thermal imaging system is very costly, you don't have that technology. Can you go for digital image processing as an alternate, cheaper form of technology? Because you're supposed to be a superpower in software. What are you doing about it? Are we thinking different? I would like to submit to many of you, we are not. If anyone challenges this, I am prepared for a debate. Okay, next. This is the structure which you need for capability development and progress ahead with new technologies. Business as usual is past. You need a knowledgeable military and a cultural change in the way we do things. And I leave this presentation with DG Claus. And right, look, the erstwhile one were the government services, DRDO, DPSUs. They are linked today. Khas karke DRDO and OFB. They are guile people, because OFB, you've broken them in pieces and they are underperforming. And by the time they recover back, it will be another 5 years to 10 years before they recover back. And there will be no use to any one of us for new technologies. You have just attempted to break the DRDO up. They are also going to be sulking for the next 5 years. Either way. One, if you break them, they are going to sulk because it's going to be a reformation. If you don't break them and they continue to have their way, they are again sulk. They say, you tried to sort me out, I'm going to sort you out. I'm talking of psychology. I'm not talking anything against DRDO. Right? In such a case, it is the industry, startups and the academia which will come to your rescue for these new technologies. And this is where the repository is. We are underutilizing our academia. Let me tell you, 7 years I've been in IIT Madras. Okay? And I've sent at least 30, 40, 50, 60 students, my students, to Microsoft, Amazons of this world. Must be something wrong in the way we are doing, that Amazon and Microsoft pick up my chaps and take them. Right? And we don't pick them up. Or DRDO doesn't pick them up. Or OFB doesn't pick them up. Army to chhod do. Are we doing something different? We say our CEOs, Indian CEOs are running their countries, their thing. Why can't they work for us? It's a structural mental change you have to do. Okay, startups. One good thing which I say, I must tell you this. 6 years back when I spoke in a similar audience, here, not here in that bigger hall, we were talking of AI, cyber and all that. And I asked this question to about over 1,000 people who were sitting. Who will get all these technologies? The unanimous answer was startups and MSMEs. I'm glad that 6 years down the line that we are hearing MSMEs and MSMEs and startups talk of this. That's one positive change. Not everything is bad. Okay. And of course, the business of BAE, ISRO and CSIR are very important in today's. When you talk of space, if you don't link up with ISRO, where are you going? If you're talking of battlefield energy, if you don't have a link up with the DAE, what are you doing? You need structural change and expansion of our capability development thinking altogether. Next, please. And things are not all bad. Look at this. This is by same Eric Schmidt whom I spoke of. He was in the Defense Innovation Board. And he talks of the US system. He says for 10 years, they take 10 years to change. It's the same problem they have and we have. So let's not get disheartened. Okay? Any change, any new capability coming in is a decadal process. Okay? So they are in the same boat as we are. It's just that we have to think differently to get there. In fact, I feel that at times we are better off than what they are. Okay? Right. I'll stop here. Last slide, please. This is something which I again showed everyone. Today, the armed forces are strong enough to defend the territorial integrity of India. On that, let's not have a doubt. And I'm proud of them. Okay? But the challenge is, are we modern enough to anchor India's rise as a regional power? All this business of technology is for that. It's not that we can't stop the Chinese or the Pakistanis. Anyway, Pakistan is a joke. We should start looking over that. But even the Chinese. Yeah. Okay. Next. This is my details for those of you who don't know me. Right? You can contact me in IIT Madras. I'm into this business for the past 7 years. We made a lot of progress in technology, which I wouldn't like to share with you, obviously. I've shared it with those who matter in the army. And it's time that we change how we do business with these IITs. It's time we stop letting these IITs go and do, be feeders to foreign companies. They have to be for us. And I can also tell you, they would be more than happy to get oriented to our own systems than go abroad. It is just that we're not making that outreach. Right. Thank you. I now request General Rajesh Pant to please talk to us about cyber security and cyber operations and how to make the soldier cyber resilient. He is an acknowledged expert and an authority on cyber security. Sir, over to you.
Deputy Chief Strategy General H, DG Claus, General Dushyant, ladies and gentlemen, I wish you a very good afternoon. Some great points have been made by General Shankar. Thank you so much for setting the stage. I have been asked to speak on how to make the soldier more cyber resilient. And I must compliment Claus for this very timely and relevant topic that they have given to me. Timely because, as General Subrata also said, on 19th of April, our northern adversary, after 10 years, has reorganized his forces, and the strategic support force has been split into 4 components, which include the information force and the cyber force. It is relevant because of the word resilient. Now, why is resilience so important in the cyber domain? Is because there are 3 hard truths of cyber. One, that as long as our systems, including the weapon systems, depend on software, vulnerabilities will continue. 2, as long as there are vulnerabilities, cyber attacks will continue to take place. And 3, the attribution, that means the source and from where these cyber attacks are coming, will be as difficult as what it is today. So all of us have to operate in an environment that you cannot stop the attacks. The cyber attacks will keep coming. How do you continue to provide business continuity, as they say, or operational continuity, as we would term it in the defense services, in the face of cyber attacks? That is what resilience implies. And how do we make the soldier more cyber resilient is what we will discuss. The first thing I feel is that the soldier must know as to what is the threat that he is facing. मेरे को क्या हो सकता है cyber domain में? And the threats that he faces are on his weapon systems, on his equipment and the systems that he uses, on his cognitive domain, on the physical threats that can arise. And then let me just take them on one by one. What can happen to the weapon of a soldier? And when I say a soldier, I mean, for all of us, it's a generic term. It could be a gunner, it could be a signals operator, it could be a guy operating the radar. For each one of them, by the way, there's a different cyber threat, depending upon what weapon he's handling. But the sort of threat that he has is something like a logic bomb. I remember there was an artillery gun that we were examining, and General Shankar is here. And we found that after a certain rate of fire, the control system of that gun jammed. It was under import. And it was designed to be like that when that rate of fire reaches that fire that is normally fired in operations, that gun jams. That's a logic bomb. I've also seen a demonstration of a missile in another foreign country where after the missile took off, they did GPS spoofing. And it was just a briefcase from where the gentleman switched on the GPS jammer, and he spoofed the GPS coordinates. And that missile, we were tracking it, it went back from where it had taken off. And it's very easy to spoof a GPS because the GPS signals, as a signal officer I can tell you, they are at a very low level. It's about 112 dBm. And even with the briefcase of a 20-watt jammer, you can easily, because you know the format of that GPS. So these are the sort of cyber weapons that can act against the weapon of a soldier. We are talking of surveillance systems. As far as the equipment is concerned, data encryption. Whatever equipment he is using, akin to the ransomware attack that take place around the world, the equipment that the soldier is using, the entire data can get encrypted. Whatever equipment, I am keeping it generic. Now you can imagine what can happen if the data gets encrypted, which is what is happening in the ransomware attacks, which is today the number one threat in cyberspace. Distributed denial of service attack, again, these are attacks that block your entire systems. The source of these attacks could be a CCTV camera. In fact, some cyber attacks have taken place where the data he has taken from a CCTV camera and he's put that data on a particular IP address. So continuous barrage of packets on a particular IP address, that system comes down. And why CCTV camera? Because you suddenly have access to a very easy and large amount of data that you can use for carrying out this attack. The radar spoofing, similar to the example that I gave you about the missile, the radar spoofing can be done. The type of aircraft can be spoofed, the distance can be spoofed, the viewfinder can be changed, the various DZs can be changed. And today, in this concept of the Internet of Battlefield Things, as it is called, and the chief in the morning mentioned the Internet of Military Things, a large number of IoT devices are today being spread in the battlefield. And these IoT devices have not gone through the normal security testing which is carried out in the cyber domain. In fact, on 9th of April, the Ministry of Electronics and IT has come out with a notification that all the CCTV cameras that will be procured henceforth will have to go through a process where they will be tested whether they have the essential security parameters or not. This is a 9th of April notification over which for the past 1 or 2 years we've been working. Since now I am the chairman of the Cyber Security Association of India, we've been insisting that your surveillance, there is no point sending spies across the border now. They are seeing you from your CCTV camera. They are all being imported from China. Finally, the government has come out with this notification of IoT devices. So, point to note is that all the IoT devices that are being inducted into the defense services have to go through some sort of a lab where their security parameters can be tested. There's a concept of a national trust lab that we have created in CDOT. 60 CR project has been given to them for this particular purpose. Threat to the cognitive domain of the soldier is very well understood by all of you. Misinformation, disinformation, all the influence operations that can be carried out, the social media aspects that the soldier is exposed to, the honey trapping that can be done, that's a threat that he must be aware of. And finally, of course, is the physical threat. Now, when I say cyber, I am including electronic warfare, because in the TBA, you cannot have pure cyber warfare coming through data networks, etc. And in all my talks, I say that it is cybertronic warfare, which is a combination of cyber and electronic warfare. Because in the TBA, if you have to infect a particular system with malware, and General Sunit showed you that beautiful first diagram where everything was connected, and most of it was wireless. So how do you enter that networks? You enter it through the wireless. That means you transmit a signal of the same frequency, with the same format, same characteristics, and try and put your signal with a particular malware inside our system. That's how you enter. So a combination of electronic warfare and cyber warfare is what we will be seeing in the TBA. And along with that, I would also include the microwave, because microwave, and when I say microwave, means high power microwave, the weapons and the laser dazzlers, etc. That would also form part of this my definition of cyber warfare. So the physical threat to the soldier would also include the laser dazzlers as well as the precision HPMs that today are being spoken of. So these are some of the threats that the soldier will be exposed to in the battlefield. That means the threat to his weapon system, the threat to his weapon, the threat to his systems and equipment, threat to the cognitive domain, and the physical threats. Now, if these are the threats, then how do we ensure resilience that I spoke of earlier? And for resilience, there's a very simple formula. It's the abbreviation for PowerPoint, PPT, and you add a C on that. So PPT is People, Process and Technologies, and the C is for cooperation. And I'll just expand a bit on that. So the people part means, and the most important thing is education and awareness. This has to be done. We have to probably involve RTRAC in this. We have to involve our regimental centers. All the soldiers have to go through training. They have to go through simulation. They have to go for testing, whether they fall for phishing mails, for disinformation, and against deepfakes. All of you on WhatsApp these days are seeing the deepfakes of President Trump and all these other people, that somebody dancing, etc., or somebody speaking in the exact voice. So deepfakes, just imagine a soldier if he gets instructions from his company commander in the same voice, the same face, that the attack is now been stopped, you have to go left or whatever, some sort of order. It can create absolute chaos in the battlefield. So how do we prevent that? So a lot of education, awareness, preventive methods have to be there as far as the soldier is concerned, the people part of it. In the processes part of it, of course, the standard operating procedures have to be there in case of ABCD. You can write all the different situations. The vulnerability assessment and penetration testing. Who's going to carry out that? This has to be a continuous process in the battlefield, that somebody has to continuously keep testing whether the systems are safe or not of his equipment and his systems. As far as the technology part is concerned, there are a number of products available from the zero trust architecture products, where you trust nothing and verify everything. That means whatever endpoint he's got, the network, the cloud, the data, the application, everything is tested, including the identity of the individual. And we have to provide him redundancy. to provide him resilience, we have to provide him redundancy in terms of both the networks as also the multi-factor authentication. And finally, the cooperation aspect. A soldier is interconnected. He is, General Sunit mentioned the MANET network, mobile ad hoc networks. Everyone is connected. So the malware can not only come from his platoon or company, it can come from a higher headquarters in that interconnected network and then target him. That's how, if you recall that famous Natanz attack in Iran, it had already infected a large number of nodes before it actually reached that facility, the nuclear facility. So the interconnected part has to be seen, and that is where the antivirus measures have to be taken throughout the networks. So the defense equipment has to also have a very strict supply chain monitoring because when I say cooperation, I also mean that which are the agencies that are involved which can create this infection in his equipment. And when you see the tier 2 and 3 suppliers, for example, just one company, Cisco, that manufactures switching equipment, it has 20,000 tier 2 and 3 suppliers. So that's where all his material is coming from. This is just one company. So you can just imagine that the defense equipment that all of us are using, what are the companies at the back end and what are the chances and the risks of infecting it through either hardware, that is through the chips, or through the firmware that is programmed in those chips. So this is where some procedures have to be incorporated from the test point of view. So let me conclude by saying that cyber security is a very additional essential part because as the chief was saying in the morning also, that it's a part of conventional warfare. There's no kinetic, non-kinetic. We are past that stage now. And by the way, there's nothing non-kinetic about cyber warfare. There's a physical packet that travels from point A to point B carrying that malware. I mean, if you've seen a hypersonic missile, nobody's seen a hypersonic missile. That also travels. We don't say it is non-kinetic. So in cyber warfare, there's a physical packet which is traveling from point A to point B, carrying out whatever attacks it is taking. And in my view, it is at least quasi-kinetic, if nothing else. I would also recommend the cyber audit reports to be part of the annual inspections. That can be considered. As also a column on cyber hygiene to be included in the ACRs. This is very important now for everyone, as to what is the cyber hygiene of the individual based on various this thing. And then we have to carry out a risk assessment of a different organization. There are ways for carrying out risk assessment because if everything is critical, then nothing is critical. So in an organization or even in the soldier, whatever work he's doing, we have to see what is the most critical aspect and then protect it with all that we can. So with that, I will end my talk today and again thank Klaus for giving me this opportunity. And while General Shankar said that AI and cyber is being repeated too often, but since the focus of the seminar is empowering the soldier, I thought we will restrict ourselves to what aspects the soldier is exposed to, and cyber definitely is one of them. Thank you very much.
Thanks a lot, sir. I think that was necessary, the way you put it across very simply, right? The way what we need to do, what the threats are. It's not that we are repeating AI and cyber continuously, but in the overall context, that's what I said. But your topic was on cyber, so you had to go on cyber, and that there's no two ways about it. The only thing I'd like to add is it time for us to start thinking offensively in cyber also? Because for long we have been only defensive. There is an offensive aspect to cyber, which I think we need to start thinking of. The second point which I'd like to make is, from morning to now, I've heard of this, Chinese reorganization of their information support force, and that they're evolved into something great. Look, I've been studying China for a long time, right? And if you really go into it, I'd like to clarify to everyone, and I'll debate with this on everyone also. If you studied the erstwhile PLA SSF, the Strategic Support Force had 3 wings. Rather, it was in 2 arms, but it had three wings virtually. It had the cyber force, it had the information force, and had the space force. And I thought that was a very lethal organization where everything was linked. And the PLA SSF was actually the fifth service of the PLA of China. They had 5 services: Army, Navy, Air Force, Rocket, PLA-RF, and PLA SSF. They have downgraded it into 3-4 arms. And if you read into the bylines and texts, I've read across the Chinese nets and everything which is in the open domain, the tasks and the capabilities assigned are same as what it was in the PLA SSF. Why have they done it? There is more political issues. My own gut feeling, and I'll have to do a little more research on this, is that Xi Jinping was too worried that so much power is vested in one guy. And if so much power on information is vested in one guy in a communist institution, that communist institution is open to subversion and takeover. We have to look somewhere else. This is not addition of capability. Okay? So take it as a watchword. What China does, you have to look beyond the immediate facade. There's a lot of information is coming that as if something new has been done. It has not been done. I'd like to put that across. Okay. I'll request George Philip, who's from Big Bang Boom Solutions, and he's going to talk to us about operating drone environment. And this is an upcoming startup which has made some headway and has got some orders for an anti-drone environment. 15 minutes, George. Take over.
Thank you, sir. Respected Chair, respected officers, respected veterans, ladies and gentlemen, it's my privilege and our honor to be here addressing all of you. Before I start, just like to take a minute to thank the Indian Army. We are a testament to the fact that the Indian Army's commitment towards not just technology absorption, but also their commitment towards developing new technology. We are a 5-time IDEX winner. Post 5 years of deep R&D, we've actually received our first large order from the Indian Army and the Indian Air Force for counter-drone systems. Now, I will just cover the following topics in my talk. I'll be looking at the nature of drone threats that we've seen in conflicts around the world today. Secondly, we'll also look at the countermeasures against drones and how it changes from situation to situation. There's no one-size-fits-all solution for counter-drone measures. Third, we'll also look at some of the procedures that have been successful in the Russia-Ukraine conflict. We'll also look at the way ahead. So, of course, I'm speaking to an august gathering of military officers. I don't think I have to dive too deep into the nature of drone threats today, but I'll just take a minute to quickly cover it. The highest flying UAVs that we have today are our high altitude pseudo satellites. These operate in the stratosphere. They provide unparalleled, unrestricted surveillance to any armed forces. We are lucky that we also have quite a few 2 Indian startups who have actually done excellent work in HAPS. The second category comes under unmanned combat aerial vehicles, both high altitude long endurance and medium altitude long endurance drones. The Bayraktar TB2, the Turkish drones, have been used to devastating effect in quite a few conflicts. Then we have the loitering munitions, such as the Iranian Shahed 136. This has also wreaked havoc. A lot of them were launched towards Israel, but of course the superior Israeli layered air defenses took them down. We also have the Israeli Harrow, the loitering munitions. Why I put them in a separate category is that they are much more autonomous than your typical loitering munitions. Next, we come up to the COTS, or the commercially off-the-shelf available drones. These drones are what we have seen a lot in the Russian-Ukraine conflict. They primarily have 2 categories. One is your high-speed first-person view drones. These are drones that are typically extremely fast, fly upwards of 150 kilometers an hour to today even 250 kilometers an hour. They're controlled by operators that wear virtual reality headsets, and it requires specialized training in order to fly one of these effectively. The second category is your tactical drones as well as your commercially off-the-shelf quadcopters, things like your DJI Mavic. The DJI Mavic, in fact, has been one of the most commonly used drones in the Ukraine conflict, wherein this particular drone has been providing unparalleled independent surveillance to units. Right? They did not have to they did not have to depend on their larger units. Smaller units, platoon level units, have carried these Mavics, carried out surveillance, thereby increasing the battlefield transparency. Lastly, we also have a swarm drones, both semi-autonomous and autonomous. A lot of developments happening from China. This is a real threat, and we'll look at this in a while. Now, before we jump into the countermeasures against drones, I think it's also important to see and to look at, how come Ukraine innovated so well with drones on the battlefield. Now, a lot of doubts were cast when Russia initially went into the conflict on how come, they fell behind, because Russian officials have had a lot of prior experience with drones both in Syria and Donbass. They've noted the advantages of using drones in the battlefield. One of it comes down to the traditional aerial doctrine that your aerial vehicles are extremely expensive and difficult to be replaced. So initially Russia was extremely cautious with these sort of unmanned combat aerial vehicles that they had. And therein Ukraine also took the advantage, wherein the biggest thing that they've done is the democratization of drones and counter-drone systems through the Ukrainian rank and file. So this really gave a lot of freedom to alter tactics on the fly. So one takeaway that we can look at from the Russia-Ukraine platform is that small tactical drones, portable handheld anti-drone systems at the platoon level are indispensable today. Now, when we talk about countering drone threats, there is no one single solution. There's no one size fits all solution, right? It is very clear that the fight over the electromagnetic spectrum will be very decisive in either raising or reducing battlefield transparency for one side. Now, when we look at the various scenarios, one scenario is that we're protecting bases, headquarters, forward operating bases, critical establishment. The second come into artillery units that were devastated during the Azerbaijan-Armenia conflict. Then coming down to your infantry soldiers and also to armored vehicles, which have suffered quite a bit at the hands of FPV drones in the Russia-Ukraine conflict. Now, coming to the countering drones in HQs and bases, one of the most important things is the layered and integrated air defense system. This is key. So it's not just electronic warfare, not just long range and smart RF jamming, long range and smart RF jamming and detection will take care of semi-autonomous or non-autonomous drones. But when it comes to the threat of autonomous drones, EOIR, radar is extremely key. Lasers and anti-aircraft guns are also important to be in this particular mix so as to take down any sort of threats. Because understand the threats today are everything from your high altitude, medium altitude, long endurance drones all the way down to your DJI Mavics. Only an integrated and layered air defense system can take this down. So when we talk about anti-drone, we've had people come up to us and say, okay, we would like to explore your anti-drone solutions. I think the first question that we ask is, okay, what are you looking to protect, or what is the use case? Are you looking at for the soldiers or the units on the battlefield? Are we looking at for headquarters? What is it? Second, when we look at artillery units, see, these were units that were decimated during the Azerbaijan-Armenia war. During the Azerbaijan-Armenia war, a lot of loitering munitions like your Harop, like your Bayraktar were used to destroy artillery, were used to destroy T-72s, S-300 missile defense systems. what is required for artillery units is definitely mobile, layered, and integrated air defense systems. Again, the systems will comprise of the similar things: electronic warfare systems, EOIR, radar, lasers, and anti-aircraft guns. Another thing that we've seen in these conflicts is that, especially of late, see, Russia has some of the best electronic warfare systems today. But even their systems are now under threat from Ukrainian RF seeker drones. And the moment you start using jamming, or you use any sort of jamming to bring down drones, you reveal yourself to the enemy, right? So we have to keep in mind that any sort of electronic warfare systems are susceptible to anti-radiation missiles, RF seeker drones. So it's important that while we use electronic warfare, it's important to really ensure that the units that are using them are highly mobile and they disperse once jamming is done. Coming down to empowering the soldiers, right? See, today one of the biggest reasons for the reduction in transparency on the battlefield is the surveillance of your small, inexpensive drones, like your DJI Mavics, your FPV drones. What can soldiers at the platoon level do, or what should be done? See, a lot of times till today, we really look at ballistic vests, ballistic helmets as just protective gear. We would like to suggest another element that can be used for protective gear, which is your passive RF detectors. See, today on the battlefield, the soldier needs to know which are the drones that are coming for him. What are the types of drones? What are the frequencies on which they're flying? These two information will themselves give the capabilities of the drone attacks that are coming towards them. Second, we also need to know and understand the direction at which the drone is coming. So small portable units which can be carried in backpacks by the soldiers will really give this capability to platoon level to really counter drone threats. In addition, we are also looking at a lot of use of handheld jammers, especially if you look in the Russia-Ukraine war. Handheld jammers from various origins are being used. Here, the key is that we need to look at tunable frequencies, because one of the things that, see, in electronic warfare is always a cat and mouse game. You have electronic countermeasures and you have electronic countermeasures. One of the electronic countermeasures that has been used very successfully now against superior Russian EW systems by the Ukrainian soldiers is frequency hopping, right? So you are not just flying your drones in your standard ISM frequencies, but also in your non-standard ISM frequencies. So example, you're flying in 2.4 gigahertz. It's jammed. You jump onto 900. You jump onto 433. This has been extremely effective. So when we look at even jamming, when at portable, it's extremely important that you're able to tune these frequencies even to non-standard ISM bands, right? And we really would look. I think it should really be considered that the army maybe look at an individual or portable anti-drone systems as part of the FINSAS program, the Future Infantry Soldier as a System, right? Another additional weapon that a soldier or the unit can have is autonomous counter-drone hunters, right? So these coupled with portable radars really give a lot of flexibility in operation to soldiers at the platoon level. Coming to armored vehicles, in response to the increasing number of attacks on armored vehicles in the Russia-Ukraine conflict, we've already seen, so if you see the picture on the top right hand side, we already see T-72s which have been modified with EW modules to basically stop these sort of drone attacks. Because understand, while autonomous drones are definitely a threat, today the majority of the drones are not autonomous. They are either semi-autonomous or completely non-autonomous. And in order to actually stop these, we have solutions. Additionally, we also can look at active protection systems being upgraded. Today, active protection systems of the various armored vehicles, they do not easily detect drones, right? Because drones are much more slower, and the way they fly is lesser compared to the speed of anti-tank munitions. So one could be looking at active protection systems based on ASAR radars. Another futuristic thing that can be looked on is that autonomous visual situational awareness. So similar to the way fighter pilot jets get a missile lock on, Autonomous visual situational awareness systems could provide autonomous drone warnings to the armored vehicles. Coming to operating procedures, see, these are things that the Indian Army already does, but in case of stealth, when it comes to drones, increased mobility, use of cover, dispersion, these have become crucial in minimizing vulnerabilities from aerial surveillance and strikes. Another thing, of course, is leave a minimal radio footprint, using RF detection to understand the drone threats on the operating zone, as well as you do not always need to use jamming. Today we have autonomous counter drone hunters, which are basically being developed, which can take out enemy drones in conjunction with GPS spoofing, which can prevent the enemy from even knowing your exact location. So I'll just show a quick footage of something that we are developing in-house. So if you can see the screen on the video on the top right, we have a drone. This is a top-down footage. We have a drone on the right, which is the enemy drone. The drone, which is signified in blue, this is a completely autonomous system which is tracking the drone, and when it comes to terminal guidance, it's going to strike down the drone via kinetic kill. Deception, this is something extremely important. I think the respected chair also spoke about this. Decoy drone transmitters, Lundberg lens on drones, these have already been developed by the Indian Army. They amplify the radio cross section of drones to make it seem as if helicopters are coming. GPS spoofing. When it comes to FPV operators, we also have drone signal repeaters to prevent the enemy from identifying the location of FPV operators, because today one of the highest casualty rates in Ukraine is that of FPV operators. Agility and versatility, changing positions after jamming due to the threat of various RF seeker drones. Versatility, it's also important to look at tactical or commercially off-the-shelf drones at platoon level with swappable payloads. It might be for explosives, it could be for surveillance. Lastly, training also comes hand in hand with operating procedures. Training for FPV pilots, under 2 minutes, sir. Training for FPV pilots, identifications of drone and drone capability. This is extremely important from a soldier's perspective. What can the drone that's coming towards me do? What is its payload? What is its endurance? What is its maximum speed? This is extremely important. Drone assembly and troubleshooting, ability to troubleshoot on the field, payload and battery swapping. Counter drone training and tactics. What is the kill chain? What is the protocols on the battlefield? If a soldier sees a drone, does he or she report it, or do they shoot it down? Now, last slide, the future. Now, we've got to understand, in the Russia-Ukraine conflict, it's estimated that 10,000 plus drones are lost, either due to EW or to actual strikes. Today, Ukraine has almost 80 plus drone companies that's supporting the system. So we really need to build the ecosystem here in India, and this is definitely possible through agile R&D and bulk orders, which can really improve the capacity of India. Development of fully autonomous drones, in GPS denied environment. This is something that our company is also working on. We've got other startups in India working on. Lastly, countering autonomous swarm drones. This is extreme. This is the future. I think respected panelists also spoke on this. Cyber attacks, delivery of malicious code via wireless networks, and of course microwave weapons. See, China today, if you look at the military periodicals, they're definitely looking at deployment of huge numbers of swarm drones to overwhelm our air defenses. So here, coming up and experimenting with microwave weapons that can take down these swarm drones becomes extremely important. Thank you, everyone. That's all.
Thanks a lot, George. I think you made some very valid points, but I'd like to add a few issues. The first thing is we have to really look at these drones in high altitudes and the efficacy of all this in high altitudes, because it's nice to compare Ukraine war, what's happening in Gaza and all. The behavior of drones, electronics, everything at 3,000 to 4,000 meters changes drastically, and especially the high altitude drones, right? The second thing is one thing which is a missing factor, a hole in this whole business of anti-drone and drone is acoustic signatures. Because world over, people have, look, a drone wherever it flies gives you an acoustic signature. It gives two signatures. I mean, it gives two, three. One, it gives a thermal signature, it gives a, electronic signature, and it gives an acoustic signature. This acoustic is something which is not yet thought of. It can't hide that acoustic signature. Other signatures it can hide, right? So these 2-3 things are there which we need to focus on. And overall, we need to have a policy. Even a drone can't fly anywhere it wants. It has to be related to terrain, right? It has to be related to local wind conditions, because these are all high altitude. These are how it is, right? You have to make an assessment of what kind of drones will operate in which kind of terrain. And this is something which we have to do and take it forward. And you have a drone and anti-drone policy. Much like EW, ECM, ESM, etc., you have to have a policy for this. Otherwise, we might be going wrong. Right. Having said this, we'll now switch to human augmentation and soldier performance by Mr. Mohan Velu. He's a scientist in DEBEL. He's going to talk of mechatronics, exoskeletons and all that. And I've had an initial talk with him. This great thing that exoskeletons are going to replace human beings and going to double their carrying capacity and all is, living in imagination. So he's going to give us a realistic thing as what can be done and not be done. 15 minutes, Mohan.
Yes, sir.
All
Thank
yours.
You, sir. Respected chair and panel members and then DJ class and the ladies and gentlemen, thank you for giving this opportunity. Let me take to the next 15 minutes, maybe an exciting presentation. What is that we saw in the Iron Man movie and Avatar, or maybe even the YouTube's videos, what is really can be made, or what are the real challenges we have. So as I said earlier, now the science fiction is becoming to the science fact. So my theme of the presentations will be on So my theme of the presentation on that, I'm a hardcore researcher and a developer from a DRDO. So let me have an introduction to my home, that's a DEBEL what it is. And then little may take an academically what is an exoskeleton introduction type, so that we can able to understand the challenges as well as that how do we make it to the reality. And the research perspective, and then the development, what the DRDO efforts, what kind of systems we made, the prototypes, and then what is the future technology is going to be there for in this kind of exoskeletons. Next. DEBEL, we are a unique and interdisciplinary defense bioengineering lab addressing the combat support and enhancement of the soldiers' life, both all in 3 air, land and water. So as we know that we are in a peninsula countries, that we need to protect the protectors, that we are very proud that we have made the systems and then research and development on this area. Next slide. We work on a life support system for the air crew, especially for the fighter aircrafts, and then underwater submarines and a military exoskeleton, strategic including ATVP, crew protections, NBC technologies, and then space technology along with the ISRO also for the astronauts. To carry out this kind of systems with the availability of the, requirement of the biology, medical, human, engineering, and all kind of electronics and science, we have an umbrella of combinations of everything that are starting from the physics, chemistry, mathematics, and as well as the medicine, doctors, engineers, and all kind of engineers together in a single umbrella. So that's the strength of our things to how do we work. And then going forward, so the core area how we work is life support systems, wearable sensors, human-machine connectivity and the capability, enhanced augmented cognitions, enhanced physical and the decision-making strength, and comforts wearers for the fighter pilots especially and submariners, and then enhanced protection and medical care technologies to address the need of the armed forces. And then the new capabilities that we work on aeromedical, which is gas separation, gas sensing, gas oxygen generations for the fighter pilot, and the anti-G protections, impact protections, and in terms of the biomedical exoskeleton, remote health monitoring, wearable telemedicine systems, and the HAPO, and then invasive protection, and for underwater, again, underwater respiratory management and emergency escape system. And whatever we develop it, what the society, for the soldiers, it's also good for the society. So the name of the few, especially at the fighter aircraft generation, whatever the oxygen generation system we made for the fighter pilots, was useful during COVID time to make the ventilator and medical oxygen plant and oxycare systems. And then coming to the, apart from the home, my introductions, so the exoskeleton, the formal introductions, what we see is that it's in the robotic. Some people call it an exoskeleton, and the robotics people call it a wearable robotics, and the doctors, they call rehabilitation physically, they call it a wearable orthotic devices. So this is in a robotic mechanical frames. The mechanical frames now is advanced, is going for the cable driven and is moved here with the soldier, adding strength and the durability. It is designed in the function of the shape of the body, understanding the three-dimensionally the soldier's movement, predictable, unpredictable movement, and able to take this robotic structure also to move along with him. So what we are trying to create in this technology is that a human functionality above the human, along with the human, and there is no time lap between should be there. So it has to work the same synchronization time between the soldier and as well as the robotic structure. If there is going to be even a millisecond of delay between the soldier's movement and the structure movement, and there is going to load him rather than actually going to help assist him. So there is a two types basically we call it. One is a passive, it's called a mechanical exoskeletons where there is a no sensors, no power system, nothing. And another is called an exoskeleton called as a powered system where there is an augmentation purpose. That means you can carry off instead of 20 kg, you can able to carry on 100 kg. And the passive exoskeleton, how it works is basically a redistribution of the weight in such a way that the lumbosacral joints is not being loaded, spine is not being loaded, and it can able to increase the endurance and the strength of the soldier. So there is a very, you can use for a rehabilitation, augmentation. It could be a lower part alone or upper part alone, or it could be passive, active, or it could be a brain control interface. The way that our brain signal gives to the muscles contracts, the same way the structure also can work along with the human functionality. So there is a people call a robotic system structure. So there is a difference between what is an exoskeleton and what is an humanoid robots. Humanoid robots works and separately with the audio, video, sensual inputs and makes its own calibrations. And it's work like a human, but not necessarily to be like a human structure. It could be on a type, biped, triped, and four leg also. But exoskeleton has to work, as I said earlier, along with the human structures. It work along with the same time, along with the human biomechanics. So it should work in real time along with the whatever the soldier does, the same it should work. This is making this more complicated than making a standalone robotic system. Moving on, this application could be used for rehabilitation where the muscle strength is being increased and then especially for the paralyzed people. And industrial also like now Hyundai, Samsung has made a separate exoskeleton thing where that even they work for a longer time is used for for an Air Force also, a load carrying enhancement, durability, endurance for the army also. It is basically reduces the metabolic cost functions, what is being especially at the high altitude. And it's also decreased the L5S1, that is the musculoskeletal injuries happens both active as well as the chronic injuries. So coming to the journey, it is not the new. We have seen the Avatar as well as in the movies in the Iron Man. But it's first it started in 1890. There is a Russian scientist called Nicholas Yarn actually made the pattern. He's not made any systems. Then Hardiman is made in 1960s, and it was weighing for 680 kg, the first structure. Then in the Berkeley in the 2004, it was the first the DARPA's program, which made look like it's possible this fiction. And then in MIT was made a rehabilitative in 2007. And moving on to the last centuries, the Sarcos is in 2008 is the one of the system which made by the US. Actually looking a very good like an avatar structure, but it can be work only in a laboratory, but not in the field condition. Then Japanese University to Tobacco made in the 2011 for mainly for the rehabilitation. Then Rewalk made by again from the Lockheed Martin. Again moved on to the human, the HVAX in 2017 by the Hyundai exoskeleton for the automotive industries. And in Hyundai and then Hulk, it was the one the Lockheed Martin which were not able to make it penetrate into the army because of these limitations. There is a Hulk in 2018. Then they moved with the BTMIA Canadian company. They made it in the Gehono, that's Monix. Now, majorly the system is being used mainly for the rehabilitation where the paralyzed people who are not able to walk, who are not able to move the arm, only made this one. Coming to the military side, where is that these challenges? We learned in the DRDO what could be a complication limitations in the last 1 year journey. It's that 100 years of his been working on this journey. It's a very bulky and weight because of the technological limitations of the actuators, especially the motors. And we put only to the joints. But the way that our human body works is not only on the joints is only at the point where you are getting a joint reaction forces, but the entire muscles is an endoskeleton our human body works. We are trying to create an anatomical structure over the body, but we are trying to create a physiological. There's a function of the human along with the human. That is a challenge. So adaptation to the human activity, everybody made a full body and the power is limited again. You can work in a laboratory but not in a high altitude. And everybody made a motion sensor but not using it the brain or the muscle sensors. So what are the critical design factors which we moved on is that rather than making a full body, let us make a functional, wearable, affordable exoskeletons that everybody can wear it, like a joint based system. And it has to be synchronized with the human movement. That's a soldier movement, cannot work like a separate structure like a robotic. And it should be whatever the combat gears the soldier carries, it should be unobstructed towards these systems. And power optimization and also the neuromuscular, that's in the brain control interface is being added. So, coming to the technological requirements, what is the technology requirement? It looks like, okay, making a structure put onto the soldier and making a motor, sense him and just make him to functional, work with him. No, it's not that. We need to understand what is the biomechanics of the soldier especially. Because each person we walk differently. The anthropometry, the physiology, the muscle function, everything is different. So, the biomechanics, soldier biomechanics is very important. Because when we've been approached by the Lockheed Martin, they said technology will give free, but we want the 2 years of your Indian Army soldiers data to us. We said we don't want your technology, we can develop on our own. So that is an important of our Indian soldiers biomechanical data to characterize how we walk, how we do the combat activity or logical activity, and what kind of forces we generate. Each person we walk differently, each muscle forces is different for the functionality. So we were studied about the biomechanics of the musculoskeletal modeling and simulation, how each person works, how each person's muscle works when they do a particular or different various activities. Then sensing technologies, how to find out the three-dimensional, predictable, unpredictable movement of the soldier in different terrains and different activity when he is doing, and how to transfer the load so that the whatever they carry, the weight of the exoskeleton as well as the payload will be grounded, they will not feel the weight. Then the control systems has the conventional as well as the brain control interface. Then put all these technologies together, a seamless integration of the technology within the technology as a system, integrated system, as well as put onto the human, then the real problem it starts. Because the motor can work in one degree of freedom, but the movement, actually the human movement acts in 3 degrees of freedom. So how you are going to restrict it, how you are going to make activate, how you are going to passive. So these are the challenges. What we faced is that synchronize with the soldiers with the exoskeleton movement, misalignment between the structure and the joint and structure joint. Because after some time even we don't feel that just adjusting our trousers, because of the gravity the trousers comes down. The trousers is not even waiting for 1 kg. But you're putting it at this kind of a structures, very huge structures, definitely due to the gravity it's going to come down. So during that time, the soldier's joint structure, the knee joint, ankle joint may not align with the robotic structures. So this misalignment, even if there is a minimal misalignment, it is going to load him rather than actually going to help him. This is another challenge. Then multi-degree of freedom. And 3 degree of freedom, how we are going to do it? Compact form factor. The availability of the actuators we are actually importing from it. Though we are in DRDO, we are making last 5 to 7 years to make it. The minimum order quantity is there a problem with our Indian industry, so that still we are making these motors, see integration of the actuators, that is the gearboxes, encoders we are getting from this one. Then there is an optimal forces acting between the soldier and the structure. What it's supposed to be. The soldier is going to give some kind of opposition to the structure. Structure is going to give some kind of a forces onto the soldier. So how this is going to be activated and optimal? Then battery is another issue. More. So the efforts what we made is that the real-time measurement of the kinematics and kinetics, that is the issue, soldiers' movements, we done it by the advanced motion capture technology, going to the field in the laboratory in the army, using the wearable sensors, and we done the musculoskeletal modeling and simulation. That means whatever the data we collected on the field on the soldiers, we put into the simulation model and made that each soldier is a specific and customization to understand how each muscles works. Then choosing the optimal structures, then optimal AI based the intelligent systems to see that what kind of the gait faces, that walking style, where to activate, where not to activate it. Then real time adaptability of a person. Even when you buy a shoe, immediately it will not feel comfortable. Over a period of time it makes you comfortable, or you are trying to get adjustability both cognitive and physically. That's a system to be intelligent to be built. So coming to our perspective, so rather than making a full body system, we understood that identify the exoskeleton configuration for a specific targeted application of the soldiers, like a walking in high altitude, carrying a load, or maybe the bending and carrying the load, unloading it. For that, we collected the real-time biomechanical data using the of the soldiers and characterized this biomechanical activity. Then the musculoskeletal modeling and simulation, and for that we help us to structural design as well as what kind of actuator is required for optimally. Made an optimal sensors, mechanisms, structures, and then actuators, and then human in loop integrated performance evaluation. Because there is no standard, there is no way to say that it is going to help the soldier. So this is a different technology to evaluate the system, whether it helps the soldiers or not. So we done with the PRTC. DG Infantry is given the permission to go with the infantry and find out what is the kind of application. So we are in a Bangalore, so PRTC centers we went, we studied all the logistic and combat operations, what they do. walking with and without payload and minimum of 5 km per hour the walking, and with a payload of minimum 30 kg, and loading, unloading of rations, combats, and artillery, so bending and lifting. These are the minimum logistics operations being done. We studied and what kind of activity we captured, and we collected the data in the 40 Jawans from the AMC Centre from Bangalore. We made them to walk in the 5 kg, 15 kg, 10 kg different weight, and understood that by the characteristics of the things. And then we also went to the PRTC and then done in the field how the soldiers collecting this data, how the what activity is doing, what kind of the thing, and we done the musculoskeletal modeling and simulation of things, so that whatever the structure we are putting, there's one side the soldier, another side is an exoskeleton, putting both into the simulation platform and trying to see what is the optimal way. Next. So then we try to make it with the payload, soldier, exoskeleton, payload, activity. These all four being synchronized to find out which is the best optimal activity, so that we can go able to wear. Then wearable sensing. We are trying to move that sensing based on from the motion sensor into whether we can have a tattoo kind of a sensing on the body, so that it dissolves after a month more. Next is the structures, how fast is to down and off by the soldier. So within 30 seconds, within 15 seconds, this structure can be done. Next to that, move on to the control system, which is the brain or the IP of this kind of a system. This can identify any kind of other things and all. So the human is going to give some kind of forces to the structure is going to give some kind of a forces onto the soldier. How both is going to optimally settle down, so that it gives an augmentation rather than the problems. So we are looking beyond the structures, the artificial muscles we are looking back based on, rather than only the electromechanical motors or actuators. Artificial muscles like natural muscles can be worn on the suit, on the trousers, on the uniform. So it's going to give a full body and a soft exosuit. So the efforts, I'll take a series slides. One is a passive exoskeleton, we made it. And we done the trials with the PRTC or the 20 Jawans, both in laboratory and in the 10 kilometers of walking in the morning and evening, or on 20 soldiers. And same thing we repeated in the AMCC Pune, also with the Brigadier Jaiswal. And then we're trying to move this month to the Leh as well as to the Tawang, to the high altitude trials. And what we found is that actually after this all these things, the validation both internally as well as outside the Jawans is that, next move, next. So these are the various graphs showing that when, so what happens is if you're taking any kind of a 20 kg or a 30 kg, 2 minutes, sir. So we have a 20 to 30% of the load comes to the shoulder for the snug fit in the shoulder. Then remaining 50% to 60% goes to the ground. That means if I carry 30 kg, then 15 to 20 kg, I don't feel, the soldier doesn't feel, it goes to the ground. The minimum, the spine offloading, that's a very important, 70 to 75% of the load is not coming through the spine. That means musculoskeletal injuries will not happen, both acute as well as the chronic. Next. Then we move on to the passive, from the passive to powered also. As I said that we made a joint based or specific activity. So we made only the knee based systems to drive it, so that we can be done in the without weight, because especially walking uphill and downhill, the infantry soldiers knows very well, officers, that 10 to 15 times of the extra load coming to the knee joint when you are walking uphill and downhill, without weight also, even normally when you are walking. So that is being done by the augmentation. Next is that you bend, carry the weight and to unload it. This also be done by the specially, and you put together this both knee joint and the waist joint, hip joint together, then become a lower part full body exoskeletons. And one more 2 slides I wanted to add it is that because it's a wearable things. We done the wearable sensing technology also of the soldiers technology of finding during a moving condition, not under controlled condition like an hospital, during a moving condition, the wearable belt can sense that all kind of the physiological parameters, which we done it and not able to give it, fully utilized by the army, but it is being gone to the ISRO's astronauts. So astronauts health monitoring is being done by us. So what I'm trying to say is that combining this technology as well as exoskeleton technology, we wanted to make a logic stick to the combat and as well as to flying exoskeleton. That's what we are looking now, the even person to fly, so that can fly for a small distance, not using micro turbines or gas turbines, fuel based system, by using this kind of actuators. And also the cognitive exoskeleton, which is nothing but the thing. So these are the 4 technologies which we are looking, coming to the academy and industry we are working. And all over that we be networked with all IITs and NITs as well as with the industries large scale for making this technology and to make this being used in the combat. And with that one, just in a lighter movement, this is the last slide, the one other thing, movie called Attack 1 is being used by the, heroes and John Aberman last year. You said that thanks to the DRDO's exoskeleton program, where that actually the soldier, infantry soldier is a paralyzed soldier after hit by the bullet, but he become functionally operational as well as the fighting hero by putting the neuronal chip along with the exo and endoskeletons. Thank you very much.
Yeah, thanks a lot. Thanks a lot for that expose on exoskeletons. All I'd like to put across at the end is this is a future technology. It's good to talk of it, good to delve into it. But whether it will be useful in battle is something which we have to see. Whether it will be useful in operations is something, or you want to use it in niche operations like mine clearing or certain logistics things is something which we have to see, right? And I want to reinforce what I said earlier. Technology is a costly game, right? It's also a seductive game, right? Sugar is good to have, but too much of sugar gives you diabetes. Just remember that. So too much of technology will not let you fight, because then you'll be fighting technology. So that is a watchword you have to take home from all this. The simpler the technology, the better it is. It has to survive battle. And the battlefield, if we have forgotten, is a bloody, dirty, violent place. It's a completely inhospitable place, right? So this is few things which we have to, as we come to the end of the day, we have to think of technology, right? The last speaker for the day, Major General Ajay Sharma, he's going to talk to us about training and simulation technology. He's the Deputy Commandant of MCME. Over to you, Ajay.
Deputy Chief of Army Staff Strategies, General Dushyant, Chair and Moderator, fellow panelists, the officers and industry representatives, ladies and gentlemen. Good afternoon. Standing before you, I'm very conscious of the fact that I'm the last obstacle between you and the beginning of the closing ceremony. And so I have to be very crisp, focused and minimalistic. I'll try to do that. And secondly, that since morning we had been talking about the technology, but ultimately it is the soldier which needs to be empowered. And that's where I, as the Chief Instructor of MCME, come in, where I'm dealing with the technology and dealing its absorption at the level where it is required. As I'm coming from MCME, I would be presenting you some use cases where we are using the topic which has been given to me. Just as a little caution, there are some slides which might appear very basic, but I can assure you that at the end all the dots will be connected. So today's topic which has been given to me is at the very intersection of preparedness, innovation and strategy. There are a few quotes which I'm giving out here, and I'm very fond of the last one, which is from the Bruce Lee, where he said, "I fear not the man who has practiced 10,000 kicks once, but I fear the man who has practiced one kick 10,000 times." And this is where exactly the simulation technologies come. These three quotes are from three different personalities coming from three different fields. One thing which is very common and which is a common denominator is that all are talking about the significance